on this computer. All right, let's go ahead and get started. So like I said, today we're going to be introducing parallels. We're not just going to be talking about parallel lines because I hope that you all already know what parallel lines are. We're also going to be talking about transversals and angles. So first of all, whoops, let's go back. Can any of you tell me what parallel lines are? I'm assuming you all have already heard this term before.
Two lines that never intersect.
Yeah, two lines that never cross each other. So that's the way we're going to define them. Just two lines that never cross each other. Plain and simple, nice and easy. These two blue lines that are shown off to the side are parallel lines. They have the same slope if they were plotted on a coordinate plane. We're not going to bother with coordinate planes for a little bit here. But these are parallel. You can see they're running in the same direction. They are not getting closer or further away, so they will never touch each other. Yeah. Transversals are a line that cuts two parallel lines at the same angle. So this red line that I just put in there, that is a transversal. And what we mean when we say it cuts them at the same angles is that the angle formed here is the same as the angle formed here. We're going to talk more about the different angles that are formed when you cut these with the transversal in a little bit. But for starters, those are the two that we want to look at. So I'll give you a minute to write both of these definitions down. We've only got 4 vocabulary words, and then we've got some new notations that we're going to have to write down and review. Does anybody need more time?
Just another minute.
Just another minute? Okay. Okay. The next 2 words are other words you should already be familiar with. So angles are the point at which 2 lines meet. Generally, it's 2 lines that are going in different directions, but not necessarily always. And then congruent angles. We talked about congruency last week in congruent versus similar shapes. So we can kind of just fill in from what we know about congruent already. Congruent angles are 2 or more angles with the same measure of degrees. So you only need to write down the 2 definitions that you see there, but I'm also going to pull up some other things talking about types of angles. We'll look at the types of angles in more detail when we get into triangles in a little bit. But hopefully you're familiar with at least some of these. So we have an acute angle, a right angle, and an obtuse angle. There's also a straight angle, a reflex, and a full angle. So these are all different types of angles. And then congruent angles. So here we see that there's this angle for point G, which is 42 degrees, and the angle for point S, which is also 42 degrees. So these are congruent, even though S is facing a different direction than G. They are the same angle, so they are congruent. And then here's 2 congruent triangles, actually. But when you have congruent triangles, each of the different angles is congruent. So we've got this one. It's congruent with this one. And then as you can see with these, so the little box is drawn in the bottom left corner here and in the top right corner here. Does anybody know what that box means?
It means it's a 90 degrees, like right angle.
Yep, it means it's a right angle. So if you see a box especially in a triangle like this, that means that it's a right angle. And obviously all right angles measure 90 degrees, so they're all congruent. And then the other way we denote congruent angles is by using either one line and one line. And then you use 2 lines for the next set of congruent angles. And if there's another set, then you'd use 3 and then 4 and then however many. So those are just representing congruent angles. Give you a couple more or a few more seconds to write these ones down. Does anybody need more time on this one? All right. So nothing to write down on this slide necessarily unless you really want to, but we're going to talk about transversals and angles. So again, we've got parallel lines right here. This red line is our transversal. And this forms 4 different angles with the parallel line. So we can see there's an angle there, there's an angle there, there's an angle there, and there's an angle there. Now, the angles that are created by a transversal when it hits 2 different parallel lines are congruent in 2 different ways. So first of all, they're congruent with each other. So what that means is that the angles formed between the transversal and this first parallel line are the same as the angles formed between the transversal and the second parallel line. So all of these are congruent. A and A are congruent, C and C are congruent, D and D, and B and B. The other way that these angles are congruent is that the opposite angles within each parallel are congruent with each other. So what that means is that A and D are congruent and B and C are congruent. And same thing here. So really what you get is just 2 different angles, A and B, repeated 4 times each. So this angle is congruent with this angle, is congruent with this angle, is congruent with this angle, and then B's are all congruent as well. And again, I used 1 line for the first set of congruents and then 2 lines for the second set. So if there's different measures, you would use different numbers of lines, which will make sense. Again, we'll talk about that stuff all more when we get to triangles. So any questions about how these setups work? Okay. In that case, if I tell you that this angle right here is 60 degrees, who can tell me what the measure of this angle is? Oh, Alyssa, was your yes that you needed more time? I have not been looking at the chat, sorry. Maddie and Lulu, that is correct. Any other guesses for the measure of that one? Good, Daniel. Yes, Emmy, not quite, Alyssa. I know what you're doing and you're on the right track, but you just barely, or you're off by just a little bit. Daphne, that's correct. Okay, so this one is 60. All of the A's are actually 60. So that one's 60 degrees, this one's 60 degrees, this one is 60 degrees. Can anybody tell me what the measure of angle B is? So this one would be a little bit trickier. You'd have to know something about straight lines. Okay, good, Camden. This is what we're actually going to talk about on Wednesday, but the straight line would be Maddie, but not the measure of that angle by itself. Lulu, yes, that is correct. Yep, correct, Alyssa. Good. A lot more of you got this than in the other class. So this one is 120 degrees. The reason for that is that if you have a straight line, this section from here to here is 180 degrees. And since we already had a 60-degree angle, we have to add up to 180. So this one would be 120. But again, that's not something you necessarily need to know right now. That's not really what we're talking about today. It's just something that I wanted to see how many of you actually had already been familiar with it. But let's look at some new notation. So one of the things I was telling last class is that mathematicians and math people in general are some of the laziest people in the entire world. So if there's a shorter way they can write things, they're going to find it. So we have some fancy little like ways of writing things quickly, so we don't have to write out a bunch of words because that's for English majors. So one of them is for line segments. You may have seen this before. We use capital letters for each of the points, and then you just connect them with this line over the top. So AB like this, written with the line over top, refers to line segment AB, which is, come on, this line segment right here from A, oops, to B. The next one, angle ABC, it refers to the angle created by going from point A to B to C. So if we started here, come down here, and then go this way. So it's this angle right here that we're referring to, from A to B to C. You'll notice that angle CBA would be the same thing. When you're writing angles in this 3-point form, which is generally speaking the more correct form, because angle B isn't quite as specific, although that is a way of writing it. So the other way I'd write it would just be angle B. But when you're doing the 3-point form, make sure the actual angle, or the point that the angle is at, is in the middle. So you don't want to write like angle CAB, let's say ACB. This refers to the angle over here, A to C to B. So that's this one. Now in this case, they both have the same measure, and measure is denoted a slightly different way. So if we put this little M in front of the angle symbol, that means the measure of the angle, and that's always going to be in degrees. So if they're ever asking you for like, what is the measure of angle B, your answer is going to be in some number of degrees. So in this case, it'd be 60 degrees. And then the last thing is this little symbol. It's an equal sign with a little squiggly line over the top, and that means congruent. So some of the ways you might put this kind of stuff together is, since this is an equilateral triangle, all 4 sides are going to be the same. These are all congruent. And marking lines with these little dashes is one of the ways that they mark congruent for line segments. So kind of like how with angles, we would use one line for each angle to mark these as congruent. We could use one dash going through each of these lines to mark them as congruent. Or if, say, these 2 sides were the same, but this side was different, you'd have 2 through this one. But in this case, these are all the same. So I might say that line segment AB is congruent to line segment BC. These are congruent to one other line segment. What is it? Good, Nick. Yep. So the other line segment that these are congruent to is line segment AC. I don't know what that was. And it doesn't actually matter which way you write it. For these ones, you could do CA. This is fine too. But this line segment is congruent to this line segment, is congruent to that line segment. And then you could say, for instance, angle B is congruent to angle C, is congruent to angle BAC. Like that. These are all congruent, and so on and so forth. Or you could even just say triangle ABC is congruent to, let's say, triangle CBA. These are actually the same triangle, but that doesn't really matter. So any questions about the new notation things? You'll get more familiar with them as we get some practice, but they can be a little bit confusing right off the bat. So one thing I do want to warn you about, though, is if you ever put angle, let's say angle ABC equals 60 degrees, I will not necessarily mark you wrong for something like this, especially if we were doing a handwritten test, but technically this is not true. You have to have the little m here to say the measure of angle ABC. So that's just something that is worth mentioning, but isn't a huge deal. You'll talk about this a lot more in high school geometry. So for now, it's just kind of notation so you can recognize it when you see it, but later on, you will actually start using this quite a bit. Any questions before we move on? Okay, does anybody need more time to write these down?
No.
Okay, then let's go to the next one. So we talked about similar and congruent shapes a lot last week. Can anybody tell me what the difference between congruent and similar are when it comes to shapes?
Similar is same shape, different size, and congruent is the same shape, same size.
Correct. So similar is same shape, different size. Congruent is same shape, same size. So my question is, what does it mean for a shape to be similar? So if we're talking about the same shape, this is a rectangle, kind of. It's not the straightest in the world, but it's a rectangle. This is also a rectangle, and it is a different size. Are these two shapes similar? Just yes or no. So they're not similar. They are the same shape. They're both rectangles. That's how we would describe both of them. But the ratio of their side lengths is completely different. So it's not just a smaller version of the same shape or a bigger version of the same shape. It's a stretched out, weirdly version of it. So they are different. Kind of like how if we had, let's say, two trapezoids, one that looked like this and one that looked like this, right? These are not the same shape. So, sorry, these are not similar shapes. A similar shape has different side lengths, but the same angles. So for this one, you can tell right away, this angle is not the same as this angle. So that's why these two are not similar shapes. The other thing that a similar shape has to have is the same ratio of its side length. So if this one is like 1 to 2, in this case, this one might be something like 2 to 10. And 1 over 2 does not equal 2 over 10. So the ratio of their side lengths is not the same. So that's why these are not similar. We're more worried about the angles right now. If we have two same angles, or if we have two angles with the same measure, what are those called? It's one of our vocab words. Anybody? Oh no. The question is, if we have two angles with the same measure, there's a word that those two angles, so like, what are those angles considered? If you have two or more of the same angle. It was one of our vocab words. There were only 4 vocab words. Okay, I'm gonna spoiler alert this one. Yeah, Daphne, correct. So it's congruent angles. Yep. So we're looking for congruent angles. Now that's a little bit confusing because we're talking about similar shapes that have the same angles. So similar shapes have congruent angles. And that is gonna be a little bit tough to wrap your head around right off the bat, but it'll make sense in just a little bit. And we'll look at an example right here. So these two shapes are similar, right? They're both right triangles. Why can't I? And I sized them down using PowerPoint to make sure they were the exact same ratio of side lengths. So we've got 3 angles in each one. Which angle is congruent to angle A? Is it
Y.
X, Y, or Z? But yeah, it's Y, correct, Camden. So Y and A are going to be congruent. Which one is congruent to angle Z?
B.
So this one. Yep. Now this time, let everybody have a chance to say it in private chat. That leaves only one set left, but what angle is congruent with angle C?
X.
That was not in private chat, but yeah, you're correct.
Well,
So
at least I got right.
You did get it right. Good job. So these are all congruent angles. Here's where it's going to get a little bit trickier, though. These two shapes are similar shapes. They both have the same angles. So what I want you to do is tell me what are the pairs of angles that are congruent. So you can just list them side by side. For instance, if you think that E and R are congruent angles, then you can just write ER like this. But try to give me all 4 pairs of congruent angles if you can. And this is the last thing that we're covering today. This is basically what your homework is going to be, is looking at shapes and determining which angles are congruent. Camden, that's correct. Nick, I think that's correct on all of them. Lulu, that's good on all of them. Camden, that's good. Maddie, that's good on all of them. Daniel, that's good on all of them. Camden, that's also good. Oh, yeah. Sorry. I assumed that's what you meant, but I was going too fast. Thomas, those are good. Peyton, those are good. Alyssa, yes. Camden, I think that's your last one, and I think that's also good. So those of you that have finished, tell me what 2 transformations do you have to do to go from EFDG or EFGD to QTSR? Alyssa, that's good. Cohen, that is correct. Thomas, that's one of them. Camden, that's one of them. Alyssa, that's good. And Thomas, that's the second one. Nick, good. Awesome. So it looks like most of you guys are getting this down pretty good. I'm going to start going over some of the pairs. So D in this bottom left corner and Q are our congruent angles in this case. E and T are congruent angles. F and S are congruent angles. It's so hard to write out all these lines. And R and G are congruent as well. 2, 3, 4. So if I were writing these out using some of our new notations, I could say angle D is congruent to angle Q. You could say angle E is congruent to angle T. I could say angle TSR is congruent to angle EFG. And I could say angle, let's say QRS is congruent to angle GDE. So those are just different ways that I could write out all of these. And then most of you that I asked about were correct. This had to be rotated some number of degrees. It wasn't an exact 90-degree rotation, but that's fine. And then it needed to be dilated to be made smaller. So all your homework is going to be about today is finding corresponding parts in different shapes. So you'll get 2 different shapes and have to say which angles are congruent or which side lengths are congruent. You can either do the math-based task transformations and similarity. It's a long math-based task, so you can either go until you get a proficient score, or you get 10 questions right. And what I mean by 10 right answers is not I skipped the step and then I just typed in the final answer. They need to be green check marks for 10 right answers. If you do the IXL, it is P16, which is congruent statements and corresponding parts. A score of 70 will get you a 3, and a score of 80 will get you a 4. So that's all I've got for today. If you've got questions or if you need some of the notes, please stick around.